Okay, hello everyone. What I'm going to do here is I'm going to evaluate some logarithms. Now, these guys here are sort of special cases because pretty often, like maybe always, when I'm evaluating a logarithm, I need to use a calculator because a logarithm, if I were just to put in arbitrarily a number into this log base 2, the result would be an irrational number. But these are special cases. What I'm first going to do is I'm going to write this as an exponent. And I guess maybe I could say an exponential equation. So I'm going to start off by writing this as an exponent, and I get 2 to the x equals 16. So the 2 is the base, the x is the logarithm, that is an exponent, and then I have 16. Well, I mean, somehow it's not that, it's a good idea. Of course, we need to know our times tables, but it's also a pretty decent idea to learn the powers of 2, to remember that 16 is 2 to the 4th. Then what we have here is the fact that the exponential function is a one-to-one property, so that if I put something into an exponential function, here I put x and here I put 4, both into the exponential function. And if the outputs are equal to each other, one-to-one means that the input has to equal each other. That didn't sound good. I feel like whatever I say about that, it's not going to sound very good. But if the output of the exponential is equal to each other, that means the inputs equal to each other. And that's, well, I guess I can see if this might help someone. But if I draw roughly the graph of y equals 2 to the x, which I'm trying to do here, what's going on is that if you have if I have, say, A and B that are not equal to each other, their outputs are not equal to each other. So if you put in for y equals 2 to the x, two different values, A and B, then their output is not equal to each other. And moreover, the only way that the output could equal each other is if they have the same input. It's a one-to-one function. It passes the horizontal line test. If I were to sketch the line, let me just draw a little dotted line here. If I put this, say, y equals 4, oops, that's not what I want to write. If I say like y equals 16, which doesn't really match what I wrote here, but say if you have y equals 16, the only way I could get that is if x is equal to 4. I feel like I'm spending way too much time on this one-to-one thing. It's a super important thing, but I'm not sure if I keep talking, it's going to become more clear at all. Notice I'm not even using the graph paper here for the most part. My dots are too big. Okay, let's do the same thing over here where I'm going to call this log 1 over 1,000 equals x. So I'm going to let it equal x. Now this is a common log. The common log is base 10. It's not really the very best sentence. It's a log base 10. And what I can do again is I'm going to write that as an exponential equation. So I get 10 to the x equals 1 over 1,000. And I'm hoping that maybe everybody will see that when I write 1 over 1,000, I can write 1,000 as 10 to the third power. I have 3 zeros, so that's 10 to the third. And running out of room, so let me shift up a little bit on all this stuff. Then I can write 10 to the x equals 10 to the minus 3. And again, exponents have a one-to-one property. So if the output is equal, the input has to equal. So, well, those are correct. I don't know about my explaining, how well that explaining went, especially the one-to-one part. But I just want to point out that just because you have two functions if you have the same function, but if you have different, if you have the input, here you have x and 4, just because the output equals to each other in general for a function doesn't mean that the x equals 4. But it's true because exponent is a one-to-one function. So if the output is equal to each other, that's the y's. If the y's are equal, they correspond to exactly 1x. It's not 1 to 2. It's 1 to 1. All right. So that's all there.